So the infimum over all open sets U that contain E, M star U, is less than or equal to the union of the measure of the unions of this Bi prime. This is an open set, and this is bounded above by M star E plus epsilon, which shows the required result. So now let me give a couple of remarks. The first is that note that if we write the supremum of open sets inside E, so this is some kind of inner regularity but with open sets M star U, then this may not be equal to M star E. This is because since we are considering arbitrary sets E, there may not be sufficiently many open sets, or there may not be any open sets which are subsets of E, and so on the left hand side you will get simply a 0, but the right hand side may be non-zero. So I am going to give an example for this. So this is the so-called modified Cantor set. So the modified Cantor set is defined as follows. So you take I0 is given by the interval 0 to 1, I1 is given by the interval 0 to some number A1, and then A2 to 1. These are all closed intervals, but the middle one has length A. So this is centered at the point half and has length A. So A1 is half minus A and A2 is half plus A by 2. So in this way we have removed an interval, a subinterval of length A centered at half. So now if you have seen before the Cantor set, in that case A will be 1 by 3, and we subsequently remove subintervals of length 1 by 3 from each of these subintervals that we get at the end of which comprises I1. But here we will not do that. Here at the second stage we are going to divide A1, then so let me write B1, then B2 to A1, then A2 to B3, and then B4 to 1. So remember that this length was A, but this length, so let me use a different color. So this length was A, so this length is A, but these lengths are A squared. So this is so of course here I am taking A, a positive number between 0 and 1, and at each subsequent step we are removing smaller and smaller subintervals of length smaller and smaller, because when you take higher powers of A it will become smaller. So the first one was A at I1, we removed a subinterval of length A centered at half. In the second case we removed a subinterval of length A squared but centered at A1 by 2. So this point here, this point is a1 by 2, a1 by 2, and this point here is given by 1 minus a2 by 2. So again we are taking the center point of each of these subintervals and then removing subinterval of length a squared. So we continue like this. So continue to define ik for each k greater than or equal to 1, removing a subinterval, subintervals. So in total at the kth stage you will have 2 to the power k minus 1 subintervals that are being removed. So for example, at the first stage this is 2 to the power 0, so one interval. At the second stage it's 2 to the power 1, so 2 intervals, and at the kth stage you will remove 2 to the power k minus 1 subintervals of length a to the power k from I k minus 1. So we have recursively defined what is ik. This is a recursive definition, and now I am defining C to be the intersection of all these ik's equal to 1 to infinity, and this is the so called modified Cantor set, and we will show lemma that the modified Cantor set has strictly positive measure if a is less than 1 by 3. So let's try to prove this. So first consider the set C prime. So consider C prime, which is C complement intersection 0 1, and we have that C union C prime contains the set 0 1. So therefore by subadditivity we will have m star 0 1 is less than or equal to m star C plus m star C prime, m star of C prime. Now I am going to show that I claim that m star of C prime is less than or equal to 1. So since on the right hand side here we have 1, and on the left hand on the left hand side we have 1, and on the right hand side we have m star C plus m star C prime. So if m star C prime has value less than or equal to 1 but the sum is greater than or equal to 1, this implies that m star C is strictly positive. So we have to show that m star C prime is less than or equal to 1. So to show this, note that m star C prime is less than or equal to the sum k equal to 1 to infinity 2 to the power k minus 1 times a to the power k. So this is the total length of subintervals removed at the kth stage. So since C prime is the complement of C restricted to 0 1, it is covered by the union of all the removed subintervals, and so the outer measure is bounded above by the sum of the total lengths of subintervals at the kth stage. So we can immediately sum it up. So we will get the sum a, the first term is a, then the second term is 2a, the third term is 2 square, the second term is 2a square, the third term is 2 square a cube, and so on. So if we compute the sum, we will get a over 1 minus 2a. Now since a is less than, assumed to be less than 1 over 3, this implies that m star c prime, which is less than or equal to a by 1 minus 2a, and this is less than 1, because a by 1 minus 2a less than 1 is equivalent to saying that a is less than 1 by 3. So we get m star of c prime is less than or equal to 1, which shows that, so we get m star c prime is less than or equal to 1. This shows that m star of the modified Cantor set is strictly greater than 0. Now if we take the supremum u inside C, u open m star u, then we will get 0, because there are no open sets u sitting inside C. So except of course the empty set, except the empty set. So we will get 0 here, but m star of C is greater than 0. Therefore the formula does not hold. M star C is not equal to supremum of the measures of all open sets inside C of the Lebesgue outer measures m star u. This example also shows the Jordan inner measure of this set C is 0, because there are no boxes B sitting inside C. So the Jordan inner measure is going to be 0, and since the Jordan inner measure is less than or equal to m star C is less than or equal to the outer Jordan measure, this implies that C is not Jordan measurable. So this is an example of a countable union of Jordan measurable sets, because at each stage the set ik is Jordan measurable, because it's a finite union of boxes or intervals. So at each stage it is Jordan measurable, but when you take the countable union, it fails to be Jordan measurable. So in fact this is even a compact set, and so this is also an example of a compact set not being Jordan measurable. So compact set not Jordan measurable. So C is a compact set which is not Jordan measurable.